Now you can say that over here also Lewis acid is playing the role of the catalyst, and without the catalyst this reaction actually cannot take place. So this is about the Freidal carbonylation. As in this case also you can clearly see in the mechanism itself that there is no step which involves the formation of the carbocation. Now students, why I am laying a stress on this point that there is no formation of carbocation, there is no formation of carbocation. Basically I spoke about this point in each and every example of the electrophilic substitution reaction. This is because in the Freidal alkylation, when I will be telling you about it, you will find that there is a formation of the carbocation in the reaction, and when there is a formation of carbocation, be it any type of the reaction, doesn't make any difference. So whenever we have the formation of carbocation, so basically it always proceeds through the step of the rearrangement basically. So therefore I will be discussing about it in detail also in the Freidal alkylation itself. So at this point I would say that this is all about the examples as well as the electrophilic substitution reactions. Now in this case, if you come to the Freidal alkylation reaction, basically the reagent for this reaction we have is the Rx, and we react this Rx with the alkyl halide, and we react this Rx with the Lewis acid again, that is, let us say AlCl3 or FeCl3. Now let us take an example. Suppose we have a benzene as a reactant. We take an example of Rx as, suppose we have ethyl chloride, that is CH3CH2Cl, and you carry out the reaction with the AlCl3. So what will gonna happen is that first of all this CH3CH2Cl will react with the AlCl3 and will form that CH3CH2 positive plus AlCl4 negative. Now this CH3CH2 positive in this reaction is basically an electrophile. So therefore now an aromatic compound will attack on this electrophile, and the product formed in this particular case would be the ethyl benzene. And again, as a result of the substitution, H plus will be released out. So therefore again H plus will react with the AlCl4 minus formed in one of the step of the mechanism, and it will form AlCl3 plus HCl. So basically in this case what you have observed is that we took ethyl chloride as a Rx. Now suppose, before going into that, I'll let you know one point over here is that when ethyl chloride reacts with the AlCl3 or any Lewis acid, what actually happens is that we have the formation of the carbocation. Likewise in this case the carbocation was CH3CH2 positive, which is a 1 degree carbocation. So basically in this case, suppose I take another example now in which I will be reacting benzene as a reactant, and I will be taking reagent as, let us say we have a propyl chloride, that is CH3CH2CH2Cl, and this will react with the AlCl3. So what will happen is basically these two will react, that is propyl chloride and AlCl3 will react, and it will form CH3CH2CH2 positive plus AlCl4 negative. So therefore now you can clearly see that the carbocation formed in this case is basically a 1 degree carbocation. And if you think about the rearrangement in this particular example, you can clearly see that if you carry out the rearrangement in this reaction, so you will get a 2 degree carbocation, that will be CH3CH positive CH3 again. So therefore in this case basically now you can clearly see why I was emphasizing there is no formation of carbocation in any of the example of the electrophilic substitution reaction. So now in this case you can clearly see that initially the carbocation formed was a 1 degree, and now the carbocation formed is of a 2 degree. Now you will carry out the rearrangement in this and will write again 1,2 hydride shift, and hence it will form CH3 CH positive CH3. Now this secondary carbocation will act as electrophile in this case. So now what will happen is that an aromatic compound will be attacking on the secondary carbocation and the product will be formed. Again, as a result of the electrophilic substitution reaction, H plus will be released in the reaction. So that H plus will again react with the AlCl4 minus and forms AlCl3 plus HCl.